Hello guys, today we are going to discuss power AC circuit, and we will discuss each and every branch of this circuit. So the first branch of this circuit is bulb, second branch is heating element, third branch is motor, and the last branch is capacitive and resistive load. Now let's start with the general formula related to this circuit. So as we know that power is actually a product of voltage and current. So voltage is represented by this equation because the circuit here is AC powered. So this is a general equation related to this network. Now here is a theta. Theta can be 0, theta can be 90. So we will discuss it later. Now the first case is a resistive element. So for the resistive we got 12 bulbs of 60 watt. So first discuss the resistive circuit. For example, this is a resistive circuit and the current flow here. So in the resistive circuit, the angle between current and voltage is 0. So the power dissipated and the power delivered to a circuit will be dissipated in the form of heat. So the power delivered to the element by a source and the power returned to a source by element. So we will discuss this by power versus time for power resistive load. So this is a graph which shows that power delivered to the circuit is dissipated in the form of heat. No power is returned to the source from an element which the power is dissipated. So here the current I1 and I2 are in phase, so they start from that same position, and the power, the average power here is represented by this curve. Now let's discuss the formula related to this graph. So for example, the average power for resistive element here is represented by Vi. So if we are taking these two elements, so we will divide this by 2. Now the power dissipated with the time t is represented by this one, is represented by this equation. If t is equal to t1, so this equation will be represented like this, t1, and t1 is actually equal to f1. So we can write this equation by this one, f1 by f1. Now let's start Now to find the average power for this element, so we represent that average power by P1. So we got 12 bulb of 60 watt, which is equal to 720 watt. In this element we got 0 reactive power. Now for apparent power here for this circuit is actually equal to average power. So apparent power here is 720 volt ampere. Now power factor for this circuit is equal to 1 because the power factor is actually equal to cos of theta, and here the theta is 0 and cos of 0 is actually equal to 1. So let's draw the power diagram. For example, this is the power diagram for reactive. We put inductive, and this is real power, this is apparent power. So now if we put real power, which is 720, and if we put apparent power, which is also 720, so from this equation we can also find power factor, which is equal to 1. Now discuss this element of a circuit. So this is a heating element. So this heating element, so the power to this heating element is equal to 6.4 kilowatt. So this is a power resistive element. So the reactive power here is 0, and as we discussed in the earlier, the apparent power is actually equal to the average power, which is a volt ampere. So this is a volt ampere reactive. VAR mean volt ampere reactive. So for this element the power factor again is 1 because the angle between current and voltage is 0. So let's move to the motor element. So here what is given? So we got an efficiency which is 82%, and the power factor here in this case is lagging. So the power output according to efficiency equation, which is equal to input divided by output divided by input. So So input power is equal to output power divided by inefficiency. So here the output power is 5 horsepower. If we convert into watt, 1 horsepower is equal to 746 watt. Now efficiency is 0.82%. So here is given in percentage. So we simply convert it. Now if we divide all these by calculator, so it's equal to 4548.78 watt. So we found the output power. Now here the power factor which is given as which is 0.72, and it is given as a lagging power factor. Now what we are going to find, we found the input power which is 48.78 watt. Now to find the average power, we are going to use a formula, this one, to find the average power, and we found the average power which is we found the average power which is 48.78 watt. Now from this equation we are going to find the apparent power. So the apparent power here is equal to divided by a 4 factor which is 0.72. So if we divide this by calculator, so it's equal to 63.17.75 volt ampere. So we found the average power, apparent power, and what we are going to find, we are going to find the reactive power. For reactive power, we are going to use this formula. We are going to use this formula. So for this formula we need a theta, but as we know that the power factor is equal to 0.72, from this we can easily find the theta, which is equal to 0.72. If we do this by calculator, the theta is equal to 43.95. Now we put theta here in this equation. What happened? The value of this was found is equal to this one and multiply by, sorry, we made a little mistake here. According to power diagram, this is equal to this one. Sine of 43.95 degree. So if we do this by calculator, what happen? The reactive power is equal to 4,384.71 voltage ampere reactive. So this is reactive power for this branch. Now to find all these for this branch, so let's start. Now here we got impedance which is equal to R plus J XC, and sorry for this, which is equal to Z R plus minus JXC according to this diagram. This is for RLC, but so according to this diagram, Z equal to R minus JXC. Before going to this branch, let's discuss the previous branch, which is motor. Now here in this graph, which tell us that the current and voltage are the voltage leading the current by 90. So this is an inductive circuit. What happened to the inductive circuit when the energy absorbed by a source, by an element, so that amount of energy is returned to a source. So here when we got a reactive element, the energy actually fluctuate from source to an element, from source to load. The amount of energy absorbed by the source or a load, the amount of energy absorbed by a load is equal to the amount of energy delivered to the source again. Now the total impedance here is R minus JXC. So the total impedance here is 9 minus J12. Now we got impedance and we got input voltage. From this we can easily find the current value. With angle 0, divided by 12J. So if we convert this into polar form, how can we do this? If we represent magnitude is equal to 9 square plus 12 square, which is equal to 15. So let's do this again. Suppose we are going to convert this into polar form. So to find the magnitude, we are simply using this, so which is equal to 15 ohm, and to find the angle, what we are going to do, and to find the angle, y divided by x. So here y is minus 12 divided by, sorry, minus 12 divided by 9. Now if we do this by calculator, so theta is equal to minus 53.13 degree. So magnitude and theta is found here in this equation. So if we put all the value here, we can easily find the current. We can easily find the current, which is equal to 87 with the angle of, so this is actually minus. So uh, when we move to the numerator, it's become plus. So 53.13 degree. So current is found here in this case. Now when current is found, we can easily find the average power. So for average power, we will put the value of current and multiply that with the resistance, which is 9 ohm. So the average power here in this case, or the real power, is 1731.39 watt. Now for reactive power, we will again use the formula of this. So if we put all the value here, which is 0.87 cross 12, so which is equal to 8.52 volt ampere reactive. Now reactive power is found. So A parent power which is S4 can easily from average power which is a resistive power and reactive power. So if we put all the value here, so our final equation will look like this. Now from this we can easily find the power factor. Now from this equation we found the power factor which is a 0.60. So as the power factor is leading, lagging, what? So as we know that for capacitive, so this network is actually a capacitive network. So the power factor deal with the current. So the current here in this case is lagging. So the power factor is also lagging. The power factor, the current here in this case is leading the voltage by 90, so the power factor is also leading. Inductive circuit is with a lagging power factor and capacitive circuit with a leading power factor. So now we got these two part. So these two part will be discussed in the next video because the video will we need to minimize the size of the video, so we will discuss this in the second part.